So let's finish up where we left off today in class. Okay, so we're looking at the particle's position after 5 seconds. So with this, we want to know displacement. Okay, so its position would be S of 5 minus S of 0. Okay, at S of 5, let's see here, we were at, right here, we were at 7.5, right? So at S of 5, we were at 7.5, actually negative 7.5 minus 0. So we are 7.5 units to the left. Now, in this case, I want you to think about, like, here we know that we were at where we were at, so we don't know that we started at 0. I'm going to say units to the left of its starting point. So I have to double check if they told us that it was starting at 0 or not. Okay, so it didn't. So this one we're just going to say to the left of its starting point. Okay, 14, we have average velocity. It's that one again, over of the particle over the 5-second time interval. Okay, average velocity, S of 5 minus S of 0 over 5 minus 0. Okay, which is negative 7.5 over 5, negative 1.5 meters per second. Okay, the average speed. Okay, so there's a big difference here between when we talk about average speed versus average velocity. Okay, so watch out for that. And I made a little note down here that if you're doing average speed, you want distance over time. If you're doing average velocity, you want displacement over time. Okay, so be careful with that. Okay, so I'm going to put in here that average speed is equal to the change in distance, or I could say absolute value, and the change in time. Okay, so the total distance, we already figured that out. The total distance that we went was 22.5 meters. And we went over 5, which gives us 4.5 meters per second. Okay, so just watch out for average speed versus average velocity. Okay, what is the particle's acceleration over the first second? And what does your answer mean? Okay, so the acceleration over the first second, when you see over, that means average. It doesn't say at the first second or when time is 1. Okay, so that's telling me it's an average. So if you want to find average velocity, or excuse me, average acceleration, that is going to be v of 1 minus v of 0 over 1 minus 0. Okay, so average velocity, let's see, did we have that in our, we have average velocity, but we did not have average acceleration. Okay, so I want you to see how average velocity was change in position. Average acceleration is change in velocity. Okay, so we're going to write it like that. And v of 1 is 5, v of 0 is 5, which is 0. This means that the velocity is constant. Okay, what time over the interval does the particle have positive acceleration? Okay, so it's going to have this whenever the derivative of velocity is going to be greater than 0, or the slope is positive. Okay, so remember that acceleration is the derivative of velocity, and that is going to happen between 3 and 5 seconds. Okay, negative acceleration, that is where the derivative of velocity, which is acceleration, is less than 0, or slope is negative. And that happens between 1 and 3 seconds. Okay, when is acceleration undefined? Well, acceleration is undefined, okay, when the derivative of velocity does not exist. Okay, so what you're going to look for here is a sharp corner. And so we see there are some sharp corners in there here, like here, and looks like here. Okay, so those sharp corners are going to be at t equals 1, 2, and 3 seconds. Okay, state the interval of time when the particle has positive acceleration but is slowing down. Okay, so if it's positive acceleration but it's slowing down, we're going to say, okay, we want this to be greater than 0, and this to be less than 0. Okay, so acceleration is positive, velocity is negative. So acceleration is positive, velocity is negative. Okay, so that's going to be between 3 and 5 seconds. Okay, state an interval when the acceleration is negative, but the particle is speeding up. Okay, let's see. Acceleration, we can look down here as well. Acceleration is negative, but the particle is speeding up right in here because the signs are the same right here. So between 2 and 3 seconds. Okay, so on 21, we want when v of t is less than 0 and a of t is less than 0. Okay, particle's acceleration over an interval. Okay, that is average acceleration. Okay, that means slope of the secant line. Okay, so the average acceleration is v of 4 minus v of 3 over 4 minus 3. And this is going to give us 5 meters per second squared. So when we're looking at acceleration, it's in seconds squared. Okay. And what is the particle's average acceleration? Okay, there it is again, average acceleration. Over the entire 5-second interval, that would be v of 5 minus v of 0 all over 5 minus 0. Which is -1 meters per second squared. Okay, and over what time interval is the particle's velocity decreasing at a rate of 5 feet per second every second? Okay, so it's decreasing and it's a rate of 5. So they're saying, when is the acceleration equal to -5? Because feet per second every second. Okay, when is the acceleration? -5? Well, if we look in between 1 and 2 right there, I can see that the slope is down 5 over 1. Okay, so I'm looking at the slope of that line. So I'm going to say between 1 and 2. Okay, oh, and then down here I have the average acceleration. Maybe we should write A. Okay, so again, we're not supposed to just go through that and then all of a sudden you have this all memorized and you're perfect at it. This is sort of in a little booklet so that you know where you can go to find things, to look those things up. Let's add these on because these are going to go to our other definitions that we had over there. Okay, so you're going to be referencing this for a little while. Okay, so what I want you guys to do is we're going to skip this part for right now about Randy the Roach. And we'll go back to this here a little bit later. But for homework, I want you guys to work on this right here, okay? At the very end of our little book. I'm not sure what number it is, but I'll put it on Canvas. Do your best. Just go back. Look up the ones that we did to help you answer all these questions. Okay? All right. Bye-bye.